answer conspiracy to your fallacious question? Can you at least attempt to
Fallacious.
steel man what flat earthers have said to you about a map? It's been 7 years, bro. Can you steel
Oh
man
my
this
God.
answer
Oh,
from us?
okay. I've heard four different reasons why you guys can't get a map, and I think Witsit's was the funniest one. Witsit said that there was a king that didn't allow anybody to make a map that didn't work with the globe. I thought that was the funniest one.
So
Was I close?
humor is your reputation.
Okay. First off, the Steelman argument for flat Earth is fallacious because there's no single Steelman for any single flat Earth claim. So you can't say, well, Steelman the flat Earth claim for X because it's like trying to Steelman a sunset. You guys have a handful of different excuses of what a sunset is. So trying to say, well, can you Steelman the flat Earth argument? No, nobody can. So what was the answer on why you don't have a navigable flat Earth map?
Okay, so I didn't ask for four. I asked for one. But even if I take your false steel man, because that wasn't really a steel man, that was just again humor.
Oh, was
The
Witsit
royal
lying?
decree in question that you mentioned from Witsit, the royal
Yeah.
decree, yeah, it's about the coordinate system that you guys use for your map. Now, wouldn't it be odd if you wanted to make a map with the distances, the measurements that you wanted, and you were told that you could not unless you used a specific coordinate system?
Who said I couldn't?
The same
Who
guy
said
you
you could?
hand dismissed when Witsit gave it to you. I can
What
pull up the paper,
what
but it
what
sounds like you're driving, so I don't know if you're gonna read
what's
it.
his what's his name?
I will grab it for you.
Please. And he has authority over who?
Well, I'm not a cartographer, but at the time, that was a long time ago conspiracy. It wasn't yesterday. But
Okay.
cartographers back then, I'm pretty sure they had rules to follow when there were
Okay.
kings
What
in
about
place.
okay, the question I had was not back then. I'm talking about today. We know how far two cities are from each other. We know how far the end of Australia is, the east end and the west end. We know how far the north end and the south end are. Why can't a flat earth person draw to scale the country of Australia?
Why can't they?
Exactly. That's exactly my point.
Well,
What's
why
keeping
is
them?
your map? Well, let me ask you a question. Why are all your globes not to scale?
All of our, what do you mean, not all of our globe to scale?
Well,
You
why
take
do
a
they say
navigable,
well,
okay, you're going to pull up the non educational Mac globes in a gift store as your proof?
pretty much in all the classrooms? Yeah.
Pretty much no. They have educational globes that are scale.
Are they in all the classrooms? Because all the ones I've seen
Does
are
that
not.
matter?
I
How
was
does that
shocked
affect? How does that affect
because
my question?
your point is we can't draw out land masses that are to scale with the distances we know, and then my point is yes, we can. You just haven't seen a
Then,
map apparently that satisfies whatever you're trying to say.
well, okay. Get a navigable map. Get a map that airlines use. Get a map that global navigation maps. They are perfect maps of the globe. Okay, in
I thought
distance
they
and
used flat Earth
scale,
maps.
perfect. Okay, to the meter.
Have you confirmed those distances?
Oh my God.
Don't
So,
pilots use a
so
flat Earth
just
Oh,
map?
real
I
quick, conspiracy, just for clarification, do you deny that your maps require corrections?
wait. Why would it? Why would it require corrections? Corrections for what?
Corrections for those distances that you're presupposing. That's the issue here. You want a perfect map. You expect us to have a perfect map. However, the maps that you appeal to require corrections. So again, do you
Okay,
deny that?
give me one example. Give me. Yes, I deny that.
Can
Give
I
me
give you
one
an
example of
example?
a correction
So they
that is required on
so,
the
so
navigable map
most globes are not actually
that we
drawn to
have.
scale.
Just what correction is required?
I just wanted you to know that.
Magnetic declination.
That's not a correction. That's the difference between the North Pole and magnetic North Pole. That's not a correction on the globe.
No, if you're traveling using globe coordinates,
A hand,
you
using a handheld compass,
okay. So
then yes, I guess that would be yeah your correction for a. But that's not the globe. That's magnetism. Not too many global navigation, air and sea use handheld compasses. At least I wouldn't think so. Yeah, we have GPS. We're now in the 21st century.
I can post a link for you of a guy who's done the so-called Antarctic race, where he talks about how the magnetic declination corrections are to hide the flat Earth because they have to have those for a globe. You laugh, but this guy's actually
I
failed
do,
that navigate. I can give you.
but I know a guy. That's
No,
that is
I can
quite the
provide you
evidence.
a link to the guy. You can check him out and see if you agree with what he says or not. That's all I'm saying.
Okay,
You're
and
saying
you said the purpose was to hide the flat Earth.
that's the conclusion he draws.
Okay, and that's tested where?
I'll put the link in the purple pill.
Oh, I'd love that.
So most globes use the Mercator
Okay, second
projection,
question, since I
which
think you
they
guys
admit
failed on
is
this
not
first
actually
one.
to
Do you
scale.
guys have a predictive model for the flat Earth?
Am I glitching?
Do you guys have a predictive model?
No, we can hear you,
Yes.
Taylor.
I
He's
can
just
hear you,
ignoring
Taylor. I
you.
just don't know if
Okay.
Capcom can, but if you want to drop and come back up, we could try again.
I was just trying to say the most globes are using the Mercator projection,
You guys
which
hear
they
me?
admit is not actually to scale.
Can you hear Taylor
Yeah,
conspiracy?
I don't think you can hear
No,
Taylor.
no, I can't hear Taylor.
That would
Just
explain it.
tell him what I was trying to share,
Is he answering me?
and I could drop down.
Say it again, Taylor. I'll relate it.
Most globes are using the Mercator projection, which they admit is not to scale.
Yes, Taylor is saying that most globes are using the Mercator projection, which is simply not accurate, and they've come straight out and told you that. It's been obvious for forever.
Okay, yeah. The
Wait,
projection is from the globe, not to the globe. Like the Mercator, the AE projection, all of those are from the globe in order to make it into a flat map that you can put on a desk. So it's not, you can't
Oh,
say
she's
that.
back up again now. You want to try her again? See if you can hear
Yeah,
Taylor
go ahead.
now.
What?
I think I heard her.
Yeah, so you could speak directly to her instead. Try that now.
Okay, I didn't hear her what her point was, which she said something about the Mercator projection.
Yeah, I was just saying that most globes that they make, um, a lot of them are not to scale, and this is why you'll see countries like America much larger, and apparently they have more like distortion in the northern portions. So I think that's pretty common knowledge. But you
Yeah,
mentioned the flight maps, and I was gonna ask, like, don't pilots use a flat Earth flight map? Wouldn't that be pretty accurate?
no. That means
Why?
the further south they get, then the east and west distances would be extremely distorted.
But you
The
mentioned
AE map is only
you
the
actually
AE map is
mentioned
only
to
good
go
for
look at the maps that pilots use as being accurate.
correct. They use the
So
globe-based
couldn't
map,
we
not
look
the
at
AE
their
map.
flat Earth maps? Is that what you're saying
They
to do?
they're no, I'm saying they use the globe-based map. They don't use an AE map. because if they did an AE map, then their distances east and west as they move south
What
would
kind
be
of map do they
extremely
use?
distorted.
Do you have
They
a name
use
for the map they use?
I don't know what the actual name of it is, but it is a globe-based map, not an
The
AE
flight
map.
maps I've seen are not, depicting a globe. I mean, obviously,
It's
I
not even
understand for
called a map.
logistic purposes, but I'm just saying, yeah.
Well, it's not even called a map.
All right,
Okay,
well, if
what's it called?
It's the deal is that what this guy is saying is not true, and what they have is WAC charts. So is World Aeronautical Charts. That's what pilots like myself fly on.
Okay,
World
but
Aeronautical Charts.
are they
And they're
to
very
scale?
precisely to
Yeah.
scale,
Okay.
1,000%
Okay, so they use the globe base or they use a flat Earth base.
flat Earth base.
So if I were to pull one up that shows me the distance between Perth and Sydney, what distance would it show?
Well, I don't know the distance. I'm not.
Okay.
I'd have to look it up.
Okay. So you know that Australia's width is pretty similar to the width
I'm
of the
I'm
continental United
I'm
States, correct?
well, no, I don't know how big Australia is to the United States, but I'm pretty sure that when uh, they make these charts, that they measure them. I mean, mile by mile, nautical mile by nautical mile by nautical mile.
Okay.
There's
So
60 not there's 60 nautical miles in a square, and then they just put them all together.
okay.
I mean,
We're,
that's how I was taught when I was going through flight school way back in the early '90s.
when they teach you to calculate distances, did they use a polar coordinate system or do they use Haversine?
I'm just,
I believe it was polar.
Wrong.
I'm just,
Pilots use Haversine.
I'm just confused as to. So you just admitted that they use a flat Earth base for the flight maps that you just said were
Nope.
accurate?
I,
Well,
I,
I'll tell you this much: when we had our books out, our books, our Jefferson's books that we had said that consider doing all your navigational uh, calculations by looking at it as if it was a flat surface.
And non-rotating, right?
I mean, that's just straight from the book. I didn't make the book up.
no, that's not even close.
The flight maps, are they accurate or not?
Yeah, they're accurate,
They're
and
accurate.
so are the world oceanic charts that ships use. I mean, now they use global positioning systems, but you say global, and people, the first thing they look at is a globe.
That's because a global positioning system is for the globe.
Whatever.
Whatever.
You're smarter than I am.
Well, I'm just saying, it's like every pilot that has to calculate distances would use the Haversine formula, not the polar position, not the polar coordinate system, because that they would be far off the further south they go. What's that banging noise?
I think it's a blinker.
Sounds like someone's blinker. But the Haverstein formula literally requires corrections, so I don't know why you just invoked that.
Can you show me where the Haversine formula needs to be corrected?
Yeah, it has corrections for the ellipsoid model because the radius is fucking bullshit. Um,
It's because the radius is bullshit. That was your answer?
you want me to use a more scientific answer?
I want a
Hey,
truth.
guy,
Actual
can I ask you?
factual answer.
Can I ask you something? Can I ask you something? Would you take a
Your
a globe from
presupposed
your?
radius?
Would you take a globe from the classroom to go navigate around the world? Would you do that?
It's too small. But if I
How big
wait,
is the screen when you're flying a plane?
Oh, I forgot Super Weather Pilot.
Well,
That might be too small too.
so when you guys see the flight path from say Santiago to Sydney, which path does it use? Does it use the straight AE path, or does it use the Great Circle route of a globe?
Why don't you
That's the
post
way
some flight
you're.
maps?
That's the way you're looking at it, because if you fly from Sydney, Australia, over to Santiago, you would basically. It would look like you're going on a globe. You would look like it was arching over, but it's actually a straight line all the way from Sydney, and you would come up through, uh, almost through China, and come right down through. Uh, the west side of the United States, and then right down through the center of
How
Texas.
far would that be?
Oh, I don't know. I've never flown that route.
So you're saying that just to get from Santiago, Chile to Sydney, Australia, you would fly up the coast of South America, up the coast of North America, over Alaska, then down the coast of Japan, then the coast of China down to Sydney?
That would be the shortest route.
Is that what
That would be the shortest route.
that would be the shortest
For
route?
sure. Yep, I'm pretty sure of it.
Okay. That would be like 20,000 miles.
Well, that's you guessing that. Why don't you go do the math?
Okay.
Why don't you look up at a
Okay,
world aeronautical chart and then do the math?
I did. And it curves south towards Antarctica and is much less, and it's only about 7,800 miles.
I'm sure you have a picture of this. Can you go ahead and post it so we can see what you're talking about?
Uh,
He's probably still driving. But conspiracy. The Earth is a perfect sphere.
not perfect. It's an oblate
All right.
spheroid.
So the Havertine formula
You know
has to
that.
correct for the fact that it's not a perfect sphere. Next.
Okay, what's the correction amount?
It depends if you want to do a short distance or a longer distance. You have to give me some numbers here.
Okay. No, the
But your
correction
claim
is
was that there's no
because
correction. So do you concede that there is a correction now, or that it's negligible? Are you changing the goalpost?
it's negligible.
Okay.
It's
Now it's
negligible.
negligible. Okay.
Well, you're saying that it had to have a correction.
And I just gave you why. Because
Okay.
the formula
Okay.
treats
But
it
you
as
didn't
if
know.
it
But you didn't know how
doesn't matter.
much.
That does
You
not
just said,
matter. It happened.
"Oh,
That
now
does not
okay,
matter. It happened.
yeah." Whether it's
It
1,000
does
miles
not
or
matter.
6 inches, it okay. Okay, I'll concede your fraction of a percent correction, which doesn't make a difference over many miles or many hundreds of miles of what you think it
Isn't
would.
this your model?
Well, I figured you guys would know the globe model since you guys are attempting to debunk
They
it.
keep changing it to a pear-shaped oblate spheroid.
Nobody changed it to a pear shape.
Oh, I thought it was sphere.
Who changed it to a pear shape?
I thought it was sphere last time.
Wait, a pear
Isn't
shape?
that what Neil
Y'all
deGrasse
just pick
Tyson
and
said?
choose. They just pick and choose when I want to believe
He
Neil
said
deGrasse,
he was
you know?
explaining that the oblateness was 20 miles wider at the middle, like a pear, not that the globe was pear shaped.
Come on. I can't keep up anymore, to be honest.
Well, keep up because your stories keep changing.
Mine? Or y'all's? I never
Yes,
said it was a
all y'all.
pear-shaped oblate spheroid in my life.
Well, neither did he. It's always been an oblate
Do
spheroid
you want me a clip where he said that?
since we've measured it.
Do you deny that he
What?
said that?
He said it was wider at the middle.
Yeah, it's chubby. Isn't that what
You
he
know,
said?
the oblateness. What?
Yeah, he said it was a little chubby.
He said it's wider at the
Mhm.
middle. Yeah, a little chubby, 20 miles at the middle, like a pear. Not that it was
You want me to keep up with all that?
Keep
It's
up
such
with
a
what?
joke.
He was to give you explain why it was oblate, not a perfect sphere.
Right.
Is that confusing to you?
It's kind of ridiculous.
Okay, well, That's not that doesn't change his what he said if you don't understand what he meant.
I was just quoting the term he used, and you freaked
Okay,
out.
yeah, like a pear,
That's your
not
dude,
pear
man.
shaped. You said pear shaped. You said pear shaped, and that's
He
not what
actually
he
does.
said. So I get it. I get it. If you have to change what he said to make your story sound
This
better,
isn't my
I get it.
story. This is y'all's.
But then why did you say pear
Because that's what
shaped?
Neil deGrasse Tyson said.
He literally did not. I just
He
told you
does
what he
say
said,
pear shape.
and you're saying
He does say pear shape.
okay, okay. So he said like a pear because he was trying to explain the
No,
oblateness.
he said like a pear, and then he said, yeah, pear shaped. I mean, we have these videos. We can put them in the purple pill.
Oh,
You can see.
cool. Purple. Good. Let's see.
Why are you arguing this? Like, does
Dude,
it
he's
make your
so
point
angry.
I
stronger
don't
or
know.
something?
It's it's because I keep hearing
Oh,
these.
look, he
Oh, your
did say
story keeps
pear-shaped.
changing. Lie.
Because he said that the
Mm,
Earth is primarily an oblate spheroid and is slightly wider below the equator than above, resembling a pear. So he called it pear-shaped.
Okay.
Are you gonna apologize?
Okay. So now you
That's
understand
what I
what
said
your
it was
point
to
was.
begin with. Are you gonna
Okay.
apologize now?
You need wait. I need to
I'm asking
apologize. Did I
if
hurt
you
someone's
are gonna
feelings?
apologize.
Sure, I'll apologize. If he said that it was pear shaped, then I apologize. But he was meaning that it was shaped like a pear because of its
Did you know that he
oblateness.
said it was
So
wider at the
nothing
so not
bottom?
a
changed.
perfect sphere, right?
Oh my God.
Wait, did you know he
So
said it was
so your
wider at the
point was that
bottom?
the story kept changing. Yes.
I
Okay.
thought the
So
pear
why
was
do you guys
just the
keep saying the story
oblateness,
kept?
but it's oblate
Oh
and
my.
wider at the bottom apparently.
Do you know what oblate means?
Absolutely. Kind of like an egg, right? And it's thicker in the middle, wider in the center.
Yes.
Okay, but then on
Yes.
top of that, he
Okay.
said it's also wider at the bottom.
Yes. Oblate.
Okay, he said, let's see, primarily an oblate spheroid and slightly wider below the equator than above, resembling a pear. I'm assuming the South Pole would be a little bit more elongated than the North Pole, would be a little pointier per se.
Okay. So
So how many hours
so
is that
you guys
flight?
lost out on the map. I get
How
that.
many hours of that
So
flight is it from
so I asked the
Sydney
He's
to
gonna
predictive
change the
Santiago?
model,
topic sporadically.
and no, I told you. That's all I wanted to do was I wanted to ask one point,
How
right?
many hours is it
Did
from
you guys
Chile to
have a
Santiago?
navigable map?
How
And we
how
pretty
many
much
hours?
figured out that no, you don't.
Wait,
Hey,
where's
how
your
many?
flight? You're supposed to post it. Whatever you're referencing,
I
so I can go look at it.
I just posted it under the comments of this show. I don't I don't know where the purple thingy is.
It's Flat Earth
Um,
Fridays. Quit playing.
Oh, the purple pill.
This show.
yeah, I posted it. It's right there
It's
on
a whole
top one.
series, bro.
Okay.
Multi-seasonal.
Okay. So the least, so the last thing that's posted underneath it is the flight path from Santiago to Sydney.
Yeah, how many hours is it?
Um, okay. And then when I asked, and this is the very very typical answer every time I get that, do you guys have a predictive model? And the 99 times out of 100, the answer I get is, well, do you? Okay. So
So are you referring to something someone said in here in particular? Or like it's like a kind of like throwing us on a bandwagon here where like, oh, because I can tell you some Globers said stuff that you probably don't agree with. Earlier, there was a Glober in Brian Sweet Space that literally said if we fly a balloon up, that the Earth is going to spin underneath it. I doubt you agree with that, so I wouldn't want to accuse you of falling in line with that.
Not to mention, we asked for a steel man and directly engaged with your point. So
Also, you came in asking for a map, but when you were asked what map you are referring to is so accurate, you couldn't name it.
Okay, sorry, I think I dropped off. Okay, so my point was we have the ability to predict exactly the location and time of a sunrise, sunset, any point
Exactly.
on Earth.
Exactly.
Oh my God!
I thought that it was
Can you?
well.
I just said.
I thought it was
Wait.
actually.
What
I
do you
thought,
What do you think when I said to the minute? What
well,
do you think that
actually,
meant?
well, time out. Because I actually thought it wasn't to the minute, and that it's like routinely 10 minutes off. So that's why I was asking for clarification when you use the word to the minute and exactly, because I was pushing back to that point.
Okay, to the minute.
Okay, it is to the minute.
Yes, and then when anybody in the southern hemisphere tries to verify it, they find out that the sun can't be where they see it. So why is that when right now, if you were in the southern hemisphere, in Sydney, South Africa, South America, the sunrise is southeast when the sun should be along the Tropic of Capricorn or slightly north of the Tropic of Capricorn.
Are you
How
referencing a
is that
point someone made
possible?
in here?
I don't know. I'm just talking
Okay.
about
Can
sunrise.
I come
So
get
right
mad at
now,
you at everything that I don't like about the Globers model?
I'm explaining the globe model, and I'm showing that it
Can I
cannot
bring up
work on the
random
flat Earth.
topics like, why does the globe say
You can,
this or that?
okay. I'm just like I
I mean,
said.
like, are
I
you
have
actually
5
addressing
questions I
anything
ask.
that was
Yes,
actually
I'm
brought
showing
up
you
in
that the
here,
flat
though?
Earth, the flat Earth doesn't work. Flat Earth doesn't have a map. The flat Earth doesn't have predictive model. The flat Earth doesn't have standard measurements. The flat Earth doesn't have any tested experiments. The flat Earth doesn't have cannot explain simple phenomena. And we're not allowed
So,
to talk about TFE, I'm sure.
Prove it.
and
Prove
can
it.
we give a list of problems with the globe model now too?
Give me your best one.
Yo, there's Capspiracy Smasher in here. Yo, Capspiracy Pusher, what up, bro? You in the car, ain't you? Yeah, you in the car. You in the car. You driving, bro? We don't want you getting in no trouble and stuff like that. You know, we want to make sure you
I
safe.
can't
But
hear you if you're
I'm
talking.
glad that you pulled up, brother. Been a long time, man. What we talking about right now?
We're talking about
I
issues.
bet you it's
He
a bunch of
started trying to
strawmans.
bring up all these issues with flat Earth, so I was just asking if we
Oh,
could
I know he not
bring
going
up
there.
Is
issues
there
with the
any?
globe,
Capspiracy, you
and
bringing
I
up
have a
problem
whole
with
list of
flat
them
Earth?
Yes.
right here. Whenever you're ready.
What? Okay, number one. What's the number one issue you have with the globe?
No
Um,
motion. Provide the motion of the orbital motion of the Earth. Go. Now, don't get crickets. You asked me. First thing is motion, then we can get to geometry. Do you have any direct measurements of Earth's orbital motion without extrapolating relative physics in order to explain away the lack of motion? Go.
What?
Smash.
that's definitely one of the points I was going to mention.
You were muted. I didn't hear it.
Cap, smash. Wait, he don't hear me? Cap, don't say you don't hear me now. You don't hear me, bro?
He's capping out.
I'm not hearing anything.
What? Yo, drop him down, bring it back up. Hell no, he don't hear me. Bring his ass back up. Tell him sacred on the mic. Tell him come back up here, bro. Nah, we not playing that. All of a sudden, I can't hear nothing when Sacred grab the mic. No, sir. Come back up, Capspiracy's pusher. No. Where you at, brother? Pull back up. Acting like your wife calling you now. All of a sudden, when I grab the mic, stop it. Oh, Roger up here too. I see Roger in my mentions, but we're gonna get to you in a second, Roger. You need a PFP. Hey, Proud, link Roger the Level Heads PFP generator because that looked crazy. It's episode 127. You still got that generic ass PFP? Come on, Roger. Anyway, hey, Capspiracy Pusher, man. I said welcome to Flat Earth Fridays, man. It's been a while. Great to see you. I said you're probably in the car right now, because you know your wife don't like you going back and forth and stuff like that. Hopefully you safe. You asked for issues with the globe Earth. The first thing that I said was, can you provide any evidence that the Earth is in motion around the sun? Any measurement, any evidence whatsoever that you don't have to relatively extract?
The zodiacal constellations.
Explain.
Every month we see a different constellation as we orbit the sun.
So the stars move.
We move through the stars.
Wait. But then what do we observe? What do we observe?
We observe us moving through the stars so that we see a different constellation every month.
How do you know that we're the ones moving?
Because of stellar aberration and redshift.
Redshift, anomalies, Halt and ARP. Not a good example. Aberration. We've already talked about stellar aberration. Do you want to get into Aries failure real quick? Because we can get into that.
Stellar aberration is not Aries failure.
Wait a minute.
What is stellar aberration?
No, he didn't just say that.
Wait a minute.
No, he didn't just say that. You said Aries failure don't got nothing to do. Wait. Okay. Let me just make sure I'm clear. I don't want to straw man.
Talking about
hold on. Let me just make sure I'm clear. I'm going to let you get the mic. You're saying that stellar aberration has nothing to do with a telescope looking at starlight from different with different angles. Are you saying that stellar aberration don't got nothing to do with Aries failure? Is that what you're saying?
Don't got nothing. Yeah. Okay.
So wait.
When
you said yes? Did you say yes? Hold on. Did you just say yes?
When Einstein listed why he feels that we're moving we're moving around the sun, he explained stellar aberration and redshift. He didn't bring up Aries failure. He didn't bring up Michelson-Morley. He just brought up the path of stars that we see as we move around the sun.
Yeah, he didn't bring up anybody. He literally made no citations. All of his papers had 0 citations. Thank you for acknowledging that. I don't know why he doesn't have any citations. I didn't know why he don't have any citations. Okay. I didn't bring up Einstein. I'm not appealing to Einstein.
I did.
No, you did. I brought up Aries failure. Now you're talking about Einstein. I don't know why we're talking about.
Okay, explain Aries failure in regards to orbiting the sun.
Okay, you guys say the reason why the starlight is not in the center is because of stellar aberration.
The center?
Yes, the center of the telescope. It's off center.
That's not what we're talking. That's not what we're talking about. That's not
stellar aberration.
Stellar aberration are the stars at the pole, the solar pole, move in a circle as we move around the sun, and the stars along the ecliptic, like where the zodiacal constellations are, they move in a flat line. So just like driving through trees, you know that the trees are moving in a certain pattern, right, as you're going through them, right?
Wait, you said driving through the trees are moving?
Okay. No, okay. The appearance of the trees are moving at a certain pattern, right?
I don't know what you're talking about. I thought we were talking about stellar aberration. Now you're talking about trees moving?
Okay, I'm trying to simplify this. Yeah. Uh-oh, Sacred's getting on the buttons. Okay.
Hey, you're behind the wheel.
Okay. When you can't tell if you're moving or something else is moving, how do you know which one of you is moving?
You go and drive.
That's literally our question.
Okay.
That's literally our question. You said it's all. You said it's
a third object, right?
You go and drive cars into trees.
Okay.
You measure the motion of the object. Okay. That's how you can tell.
Right. Exactly. So if you're moving and another car is moving, right? How do you know which one? If one car appears to be moving, how do you know if it's you're moving or he's moving?
You have to be outside of the frame. You have to be outside of the frame of reference.
Correct. Okay. So what we do is we look at stars. So we're not saying, are we moving or is the sun moving? Well, let's look at the stars and see what pattern they're moving in. And we find out that as the farther north of the sun, if you were to look, in the path of the solar system, if you look straight up, you can see that the stars are moving in a circle as we move around the sun. And as they move down, they become more of an oval. And then when you look flat across to the zodiacal constellations, they appear to be moving flat. That's stellar aberration, so that you can easily tell that we are moving. Then you look at redshift, and you can see.
Well, you want to do 2 points? Okay, I'll let you get 2 points. I just want to do 1 point at a time. Go ahead, continue.
Then redshift is as we're moving towards the stars on one side of the sun, we can see that the stars are getting moving towards us, so they're blue shifted, and you can see the stars that we're moving away from are red shifted. And so that way you can see that as the light changes from the stars, you can tell whether you're moving towards them or away from them. And so there's 2 easily tested points that show that we are moving around the sun, and they can be easily tested and measured.
Okay, you done?
Yeah.
Okay, you told us that the stars were moving. Then you told us that the sun. Hold on, bro. Damn, I just said is you done. The first thing you want to do is interrupt when I say one thing.
Yeah, I is done.
The first thing that as soon as I open my mouth, you want to continue? I'll let you continue. Go ahead, conspiracy pusher, since you want to interrupt. I know it's uncomfortable, but you did tell us that the stars were moving.
You're trying to correct your straw man. Go ahead.
What do you mean? You just told us the stars are moving. Do you want me to replay it for you?
Appear to move.
No. That's not what you said. You said the stars are moving.
Appear to move in a circle as they.
Okay, so the stars are moving in a circle. Okay.
They appear to move in an oval if you look up to the 45 degrees, and they appear to move flat when you're looking at flat across the solar plane.
So the stars are moving and other bodies are moving, and that means we're moving.
Appear to move. Why do you keep changing that?
Okay, so the stars appear to move. Okay, look. The stars appear to move. Other bodies appear to move. But that means we're moving.
Yes.
Why wouldn't it be the stars and the other bodies? Why? Hold on. I'll let you go. How many times you gonna interrupt? I know it's uncomfortable. But just follow me real quick.
Okay.
Why aren't the stars and the bodies just moving in the sky?
Because then they wouldn't have that pattern.
What do you mean? We literally have this all mapped out via the Neo-Tychonian model. All the bodies move above our heads, right? In the Neo-Tychonian model, we have a geocentric Earth, and then you say the stars are moving. Why can't the stars just move in that pattern? I'm just referencing y'all. I'm just
Neo-Tychonian is not even referenced in VSOP.
I'm just referencing your science.
Okay, Neo-Tychonian is not my science.
I mean, it is. It's coming from the scientific community.
That is a very, very fringe opinion with no measurements.
No measurements? Where's the measurements of the globe Earth in motion? That's what I asked for.
Right. We have the VSOP.
Did you have any?
We have the VSOP ephemeride that measures it and measures all the planets and the sun and most of the large asteroids. Okay, the VSOP is out there and it's been tested and measured and validated. That's how we know eclipses happen.
Does that measure the Earth moving?
It does.
Oh, can you post that? Because I've never seen it measure the Earth, a measurement of the Earth's motion. Please post the orbital motion.
The VSOP ephemeride.
I've never seen a measurement of the Earth moving. I've never seen it. So if you could post that, I would love to go over.
Okay, when I get a chance, I'll post it on the. But look up VSOP ephemeride. That's how we know. Was it 2 days ago? We knew that Mars was going to be eclipsed by the moon.
Yeah, we've mapped that out geocentrically already.
We didn't.
Yeah. Oh well, I'm sorry, not me, not we. Y'all did. The scientific
Neo-Tychonian model. The Neo-Tychonian model says that Mars
look, it says it right here. The Newton-Machian analysis of Neo-Tychonian model of planetary motions. They've already mapped these things out for the geocentric Earth. The next thing that you had talked about was redshift and blue shift. Yeah. What does Halt and Arp say about redshift and blue shift?
I don't know. I didn't talk.
You don't know who that is?
Nope.
Okay, well, Halt and Arp made some observations of, I believe it's quasars, and they seem to have the opposite of what was the prediction. I think they was showing blue shift when it should have been red shifting. And then they actually came out with, and then they took all of his access to the telescopes because he was like totally debunking redshift and blue, or our interpretation of redshift and blue shift.
Cool story.
And then they put out an article saying that magnetism actually affects redshift and blue shift. Did you know that?
Magnetism?
Yes, bro. Did you know
God.
that?
Sure.
Yo, this is not flat earthers that's saying this. I'm just asking you if you know. I mean, I could go grab the article.
Yeah, there's 1,000 claims out there that I don't know. That
hey,
I'm
bro,
sure.
Welcome to Flat Earth Fridays. I'm glad that because every single time you show up, you learn something.
No, you made a claim. I didn't learn anything.
No, it's not my claim. No, it's not my claim. This is an actual.
Somebody said.
This is no, it's not somebody. This is your science. This is a scientific community. Yes, this is a scientific community, bro. This is not a flat earther.
Okay.
And he's not. I don't even think Hall and Arp was a geocentrist either. I think that he was a heliocentrist. So he was an astronomer, and he made observation of these planetary bodies, and they were observing blue shift where there should have been red shift. And they was like, well, wait a minute, bro. Hold on, bro. Yeah, it was quasars, right? Exactly. Oh, so you do know about this. Cool. So I'm just
going off of your word.
Okay. Well, you don't have to go off my word. You can just look it up. Or you can tap in with a matter of fact, I'll go link matter of fact, Proud, can you go search up the link dropped by Alan for Hall and Arp? And then maybe Conspiracy Pusher can go ahead and do some research and double back the next time we go.
It's in the Jumbotron. I also want to add that Conspiracy, do you want to take back you saying that Aries failure has nothing to do with stellar aberration?
I was just about to get back to that.
The stellar aberration that I was talking about had nothing to do with Aries failure.
But it's the same concept of an object in the distance. If you're looking at something near, it's not going to appear to move. It's the same concept.
No, it's not. That's not what we're talking about.
That's not stellar aberration.
Apparent motion of a star.
Right. The apparent motion of the star, and you're extrapolating that motion relatively to say that we're moving. That's what you're doing. Correct. When really, the stars and the planetary bodies could just move. As a matter of fact, if you are going to move. As a matter of fact, before you interrupt, if you're going to appeal to Einstein, which is super funny, you have to acknowledge the kinematic equivalence because it's all about relative motion. There is no excuse. There is no, bro. You invoked Einstein. I didn't invoke Einstein. I was talking about Aries failure. So I'm glad you brought up Einstein. If you're going to bring up Einstein, you have to acknowledge the validity of the apparent motion of the other bodies, and not just us being moved. There's no absolute frame in Einstein.
Right. Everybody's moving.
No, that's not what he says. He says, yo, it's equally valid that the Earth is stationary and the other bodies and the other stars are moving as well. He says that. You literally
early in his work, he said that.
You mentioned it. You brought up Einstein.
Yeah, yo, bro, you brought up words.
Bro, I didn't cherry pick. What am I leaving out?
That he believes that we still move around the sun due to stellar aberration and redshift. Why did you leave that part out?
No, I didn't leave that part out. That actually makes our position stronger. He said, even though I believe that we're moving, geocentrism is valid. That's called being intellectually honest. He said there are no measurements. Yo, look, bro, you don't gotta interrupt just because I get to talking. Bro, you don't gotta interrupt. Yo, I know you want to censor me, but you don't gotta do that. I'll let you speak. Just because he has a belief, which is what you have, he was actually intellectually honest and say, hey, bro, I had never really considered the Machian principle, thanks Ernst Mach, where we could have this translation of motion down to the Earth, and the Earth could be stationary and everything above us could be moving. He said he never even considered this. And then he says, even though I believe that we're moving around the sun, can't validate it. So it's just like, I don't even know why you would sit there and say that he proved, or this is evidence that the Earth is in motion.
That exact speech, he mentioned stellar aberration and redshift.
Yes, and we can explain this from a geocentric position, which is what I'm trying to explain to you. Did you not know that?
But you can't.
What do you mean you can't? Explain why we can't.
Okay. Explain how we see stars appear to move in a circle above and below the sun, how we see stars moving at an oval 45 degrees to the sun, and they appear to be moving flat along the solar plane. Explain that using any one of your stories.
The stars are moving due to our position on Earth and our perspective. We see the move in different ways. It's very, very simple.
And it matches our orbit around the sun.
It also matches a geocentric position because even Einstein says it's all relative motion. Either those things can be moving or we could be moving.
Cherry picking Einstein is not helping you.
Yo, what's cherry picking? If he says, yo, even though I believe, oh snap, hold on.
He said,
even though I believe that we're going around the sun, geocentrism is equally viable.
Is that the only time you ever spoke?
No, he spoke mad times. He actually spoke more times when without referencing other people that he took his work from. Which is why I don't even know why you're even invoking him, because he took all of his ideas from other people and never even cited them.
Right.
Everything about Einstein is relative motion. That there is no absolute frame, that since we're within the solar system, since we're on the Earth, we're not outside of it, there's no way to actually tell. It's just an extrapolation. It's just a blind belief. And all those things can be explained from a geocentric position.
But they can't.
You keep saying nuh-uh, but you're not actually addressing the point.
No, you keep saying they can be addressed with geocentric, but you haven't shown any way they can. Just knowing the path of Mercury and Venus debunks the geocentric model.
I just referenced the paper that explains this from a geocentric position. Are you aware? Are you aware? Do you know who Luka Popov is?
Yes.
So then why are you using this as evidence if he literally says, hey, here's all the math for a geocentric position, and using your own mechanics, bro. He said, yo, we can keep the scale where it's at, we can keep Newtonian gravity, and we will still have these same observations from a geocentric position. Now, if you want to challenge Luka Popov's paper, it's right there in the nest. Feel free to go through it and show me what's wrong with it. I've been asking everybody to do it, but you can't just say. You can't just say
about his work is
you can't just say no.
The best part of his work is that the globe geocentrism. Is that the new? Is that what we're switching to after TFE?
You know, that's so funny that you say that. Can you please reference in his paper where he mentions any geometry of the bodies?
Wait,
don't go trick this. That was a question. No, don't laugh. I know the nervous laugh that's not going to get you away from question. Let me repeat it. Can you reference in his paper?
Because I don't have your cool buttons that make the cool buttons and the.
Oh no, yeah, we got the
cool buttons.
Yeah, we got your laugh in one of my intros. It's super funny. You sounding so like nervous and stuff. Hey, can you reference in his paper where he mentions geometry of the bodies in motion? Yes or no?
No.
So then why would you say that this has any?
Is a globe.
Can you reference in his hey bro? Can you reference in his paper where he has any geometry of the bodies in motion?
I'll find it for you.
Oh, so you don't have it?
I don't have it at the steering wheel right now. That's correct.
Oh, that's tough.
Thank you. Thank you, Sacred.
That's tough.
I don't have it at my steering wheel right now.
That's tough, bro. That's tough. You're on the internet all day. I think you would know about this stuff. So why do you think that geocentrism has anything to do with a sphere?
You've been in this conversation way too long, bro.
Uh-oh, she's trying to cut me off. So the whole geocentric model is based off of space objects, right? The Earth moving around the sun moving around the Earth. So
what a question. Are you continuing?
I'm continuing.
Oh, okay, so that was rhetorical. Go ahead, finish.
No, that was factual.
Oh, I thought you wanted an answer. So do you want to answer or not?
I didn't ask a question yet.
You did ask a question.
Oh,
gaslighting.
You don't remember what you just said 30 seconds ago? Continue, conspiracy pusher.
Okay. So, geocentric model is stellar objects in relationship to each other, right? So, geocentric says that all these objects move around the Earth, and they would have to be the same scale as the heliocentric model, correct?
No, not at all.
Really? So you have a geocentric model where the sun moves around the Earth at 3,000 miles, or whatever the latest flat Earth distance the sun is?
Yeah, no, this is why I brought up Halt and Arp, which you were unfamiliar with, because he said if our interpretation of redshift is incorrect, then the universe can be way smaller than what we're interpreting. And then again, the only reason why we are putting these things at vast distances is because the stars don't change. They said, well, the reason why the stars don't change has got to be because there's no medium there. Otherwise, this makes no sense why we're moving all these millions and millions of miles per hour and the stars just never change. So it can't be a medium there. Otherwise, we wouldn't see it the way that we see it. So they got to be super far. And even when we do see them, even when we do see them, the stars go in the wrong direction. We talked about negative parallax a lot, and y'all all spiraled out of control. I know the nervous laugh every time I bring up a point that you can't.
You guys bring up terms you don't understand.
I know, bro. I know. You gotta move. You gotta move the stars to different distances. I get it, bro. I get it. I know it's uncomfortable. I know it is. But listen, bro. All I'm saying is, when they actually count, well, you tell me. Where do they account for the geometry of these bodies in orbital mechanics or any type of geocentric or heliocentric model? Where do they account for the geometry?
Visually.
In the calculations is what I'm talking about? Because you're talking about models, right?
Okay. Visually, they can see that all the objects are spheres. We can see that the Earth is a sphere. Okay.
We can see that the Earth is a sphere. Okay, well, before we get to all that, bro. Okay. When we look in the sky, we see a cyclical nature. Right?
Yeah.
Right. And we do see something that looks circular, and y'all interpret those as spheres. And I'll even give you that. The things in the sky, just to level with you, let's just say the things in the sky are all spheres, right?
Yes.
Why don't they account for the geometry of those bodies in the calculations? Why do they reduce them to point masses?
Because the calculation is just for location. It's not for shape.
Yeah, why is that?
Because we just need to know where they're at. We just need to know when Venus is going to be eclipsed by the moon. We just need to know when Jupiter is going to have where the location of its moons. We just need to know where Neptune is going to be at. Uranus is going to be. Jupiter is going to be. We all have that perfectly mapped. There's a handful of apps on your phone you can pull those up, and it matches exactly what we see.
Yeah, kinematically, the motions are not perfectly mapped. They're actually reduced to simplify, because when you do account for the geometry of these bodies, guess what happens to the prediction?
How far is this error?
Guess what happens to the prediction?
Tell me.
It becomes chaotic.
It does not.
Wait. You're saying
chaotic. We have all the planets mapped, and we can put them in a cool little app on your phone, and you're saying, oh, it becomes chaotic. Except the phone app matches exactly what we see.
Except they don't. Except that they don't. They just implement spheres on your screen, even though the calculations treat them as point masses.
Right. Location.
Yes, right. Which means that they're not spheres. Why are you telling everybody they're spheres if they're treated
as spheres?
No, I know we could see them, but when you
that's
calculate,
the whole point.
Yeah, I know.
The VSOP
doesn't need to calculate. You do need to. No, when you invoke a causal, listen, bro. When you invoke a causal mechanism of gravity, it's mass dependent, which is really energy dependent. But I'm not going to cook you over that on that point. It's mass dependent, and when your spheres become oblate, like you were confusing with a Taylor, your gravitational fields are not equally distributed, which means all those gravitational fields interact with each other unevenly, causing chaos. Which is why they reduce them to point masses. If you did account for geometry and the masses of all those things you claim to be the sizes and shapes of, it becomes chaotic. Now, I could cite that. This is not a flat Earth claim. This is the scientific community. As a matter of fact, I just got off TikTok a couple weeks ago talking to a PhD physicist who literally was trying to map out these orbits and couldn't come to any conclusion because they become chaotic.
No.
What are you saying no
You were
about?
talking to a PhD? What's his name?
There?
What's his name?
PhD Jorge. He literally hosts TikTok lives trying to quote unquote solve.
He can't.
Wait, hold on. You asked me. Hold on, let me give you the sauce because I know you only stay here and you don't go nowhere else. But he literally holds these TikTok lives and he tries to solve the n-body problem, and they can't do it. They can't do it when you account for all the variables. So I don't know why you're laughing nervously like I'm just. No, listen. I know. I'm gonna give you the mic back. You don't gotta interrupt. I don't know why you're laughing nervously when I'm just referencing. Yo, it's comedy because why? You don't got no answers? That's funny, I guess. Yeah, you're right. It is entertaining. But look, bro, when they account for the geometry and the masses, the orbits become chaotic. Do you want me to cite something so you can read it yourself?
Sure. Please.
So you don't know that. Bro, you don't gotta keep. Oh my God,
this is hilarious!
It's a conversation.
You keep making these claims, like, well, you don't know that once you impose 3 bodies, that the formula goes out the window.
Hey, sorry, bro. Y'all should figure that out. Why it took you so long? And it's funny that you talking about mapping the sky because and they all treat them as point masses. Don't they?
Okay.
Don't they? Do they treat them as point masses, conspiracy pusher?
Because we already know the mass.
Conspiracy pusher, when they do the calculations using VSOP, do they treat them as point masses or they treat them in their actual masses with the geometry included?
We know the mass.
Not what I asked.
That's how we treat them.
Not what I asked. In the VSOP. Let me just go look at it. What's it called? VSOP?
I haven't looked up. I can tell you.
Oh, please, Taylor, go ahead.
Yeah, so basically the 3-body problem is like y'all already know what it is, right? And so they're trying to solve this using different ways, right? And so one of the things they'll do is they'll make one mass negligible compared to others, such as the Earth, Moon, Sun system. That's a way to kind of work around their 3-body problem. But that's what I was also going to mention. That's one of my few things in the list of problems with the globe. So anyway, that's a real thing. And there was a couple other claims you made that I've been looking up and quote fact checking that were wrong, like what you said about Einstein and a couple others. So you just gotta learn to be, try to have your facts straight, be a little bit more honest.
They're wrong, trust me.
Yeah, we already proved you wrong, starting with Neil deGrasse Tyson and him calling the Earth pear-shaped. I mean, seriously, from the get-go, like people were calling you out for
not realizing that your maps require corrections, and now you're failing at 3-body problem. So this is
okay. VSOP has how many bodies are in VSOP? Ephemeride. If we can't do 3-body, if we can't do 3-body problem, how many bodies are in the VSOP ephemeride?
You said over 2,000, and I'm gonna accept that answer.
That's close, very close. I said 24.
Oh, I thought you said 2,000.
Oh my God.
No, I literally thought you said 2,000. That's why I said I'm gonna accept that. I don't know.
We have all the planets and the major asteroids, and the sun. So.
And do they treat them with the geometry in the calculations, or do they treat them as point masses?
They give them as a mass.
Point masses?
You know what the mass is.
Or the geometry, with the actual masses.
We apply Kepler, and we know exactly what their orbit and ellipse is.
Yeah, Kepler's all kinematics. They don't account for geometry or masses.
They don't need to.
Yes, they do, because when you use a causal mechanism of gravity that is dependent on shape and mass, it becomes chaotic because you have a causal mechanism of gravity, which is dependent on the very thing in question. You didn't know that?
Sphere.
Right, and y'all don't account for that.
So how much dark energy did they have to invoke in that conspiracy?
Dark energy is hypothesis.
Oh, I'm sorry. Dark matter for the galaxy.
Dark matter is a hypothesis.
Right, and it's required.
Did they have to invoke that for your? Yeah, did they have to?
It's a hypothesis. They don't have to invoke anything. It's a hypothesis.
12-body problem equation. Did they include?
There's no dark matter in the solar system. There's no dark matter. No dark.
Is that
Really?
a fact?
Yo, what is
All right,
happening?
let's fact check him
Okay.
I
again.
mean, I agree with him. Let's not challenge that. I
Let's
agree. There's
see.
no dark matter. I agree.
Why
He
would we
needs
use
it.
dark matter within the reference frame of the solar system? That's not what the hypothesis is.
So it says 45% of the solar system of the gravitational force in the solar system may come from dark matter, with 55% normal. Well,
Okay,
this is
that's a
because, let's be
hypothesis.
honest, why are they even saying this? Because their
That's a
equations don't
hypothesis.
because their equations don't work. Period.
Okay. If you had a big ocean container and you know that there's 10 items in there that weigh 1,000 pounds, and you lift up the ocean container and it weighs 10,000 pounds, would you hypothesize that there's 9,000 pounds of something else in there?
How do they even know these things weigh 10,000 pounds or whatever they weigh? Isn't that a huge extrapolation?
Speculation.
Yeah, we know the orbits. We know Kepler. We can back calculate what the mass is. If we know what the orbit is, then we can calculate the mass.
Yeah, offer 2 bodies at a time. When you start to use 3 bodies, bro, it becomes chaotic.
Yes. So 2
So
bodies.
why are you cherry picking and not giving? And why are you cherry picking and not?
You got a great point. You got a great point.
Yeah, I know, and you don't.
If we know the orbit of Neptune,
this is great.
We know how long it takes for the orbit and its path. Then we know its mass.
Listen to this, bro. The confidence in planetary
Hold on,
mass.
Taylor. Hold on, Taylor. Let me finish this point. Now we'll pass.
Y'all have to let me say this after.
We know the orbit and path of the Earth, and it matches the mass. We know the orbit and path of the Venus. We know its mass. We know the orbit and path of Jupiter. We know its mass.
Do you know the accuracy of those masses that they're telling you? Do you know the percent confidence in those, by the way?
I'm sure you're going to tell me.
Okay, I didn't either. And it says typically around 5 to 20%. Rocky planets have a precision of 5 to 11%, bro. This is a joke. Did you know that? I didn't know that either. That's crazy. By your confidence, you made me look it up and realize how unconfident they actually are in these masses of these planets.
Okay. So we know. So Sacred confirmed that the shape and geometry match what we see. And so we know the path of the Earth. We know the path of Jupiter.
Don't go throwing me into that. I did not say that. Why would you say that?
Well, you can't.
I literally did not say that at all.
Hold on.
I've been challenging you this entire time. Why would you say that?
Do you think all the objects orbit the Earth in geocentrism?
I don't say orbit, but there is a cyclical nature that was mapped out by. Hold on. There's a cyclical nature that was mapped out by flat earthers and given to the Greeks. That's how we got all of our information that we use today.
Okay, so these objects go around Earth?
Yes.
Okay. Can you point to me any time in that the Sun and Venus are more than that are 180 degrees opposite of each other?
Oh, I have no idea. Like, why would that be relevant? Explain to me.
Because that easily debunks geocentrism. If all these objects orbit the Earth or go around the Earth, then at some point in time, Mercury would be opposite the Sun.
And Mercury
never gets away than a handful of degrees from the Sun because of its close orbit to the Sun. Same with Venus. The Venus is inside the orbit of the Earth, so there's no point in time where Venus would be off.
Bro,
okay, let Joe hand again.
I literally, again, Neo-Tychonian model maps all of this out.
Then you should be able to find the point in time where Venus is opposite the Sun.
Joe Hanvey, go ahead.
Venus and Mercury debunk your model, man. You just said that Venus and Mercury are inside of our orbit. That means they're on our day. That means they're on our day side. We would never ever look up into our night sky and see Mercury and Venus. Go outside tomorrow night and look at Venus. Okay. You're looking up into the night sky. That's impossible in your heliocentric model.
Do you know why? Do you know why we see them only just before sunrise and just after sunset?
Do you understand what I just said?
Yeah. There's
You're
no
looking
point in
up.
time
You're
because
looking up.
it's that they're
You're
too
looking,
close to the sun to see when the sun is up.
if they're inside of our orbit,
Yes.
their dark side is facing our day side. You would only ever be able to see them, if it were even possible, looking directly at the horizon at sunset. Period. You would never look up into your night sky above 30 degrees and see Venus. Period. You wouldn't do
But
it.
that's how much it's off the sun in its orbit.
It's inside of our orbit. We have a
But it
day and
still orbits the sun.
yes, and it's inside of our orbit.
Right.
So
So that why it's only visible just before sunrise and just after sunset.
I have pictures of it at
4
11:41.
hours. Today, just today, it was present 4 hours after sunset, at least.
Correct.
I have pictures of it at 11:41 at night.
Now track. Do you have one of those cool apps that track all the planets?
I just told you I have pictures of Venus at 11:41 at night.
As you should, because the orbit is that far off of the sun.
Oh wow, there's just no hope.
Wait, you can't picture how orbits work? Why is Mercury orbit off of the sun so close to the horizon, and
You
Venus
can't
is still a bit further
you
off the
can't
horizon?
picture how orbits work because you don't realize that two bodies orbiting inside of Earth's orbit, they also have a terminator line. So therefore their day side is facing the sun, their night side is facing our day side. They're inside of our orbit. Our terminator line does not allow us to see them. You don't understand orbits, not me.
Well, you just said that we can't see them, and here's a picture of them. Okay.
Under the heliocentric model, we
No,
should
the
ever.
heliocentric model dictates that we can only see them before sunrise and after sunset.
Up to
And
midnight?
that's provably false. That's provably false.
Oh, please prove that.
Up
I
to
would love to see that.
11:30 and almost midnight, you can still see it?
When it's at the furthest of its orbit, it's going to be up high in the evening, and then it's on the opposite side. It'll be up high in the morning. Why is it only one side or the other? Why don't we see it on both sides? Why don't we see it? Why don't we see it both in the evening and the morning?
You shouldn't see it at all. You don't get that.
So you claim.
No.
And we've seen your models. No. We've seen your TFE models. So I wouldn't really jump to you for trying to explain the heliocentric model.
Well, you're not explaining anything, just interrupting people and
poisoning
spewing
the
More fallacies.
Well, all I've heard so far was no.
No, you didn't. You got citations. I reference papers. I reference the math within them papers, and you have no refutation. Don't sit there and try to straw man, try to gaslight the whole audience. You haven't posted nothing to the net. I don't see nothing up here. I don't see no refutation. I don't see no acknowledgement of any of the things that we have said at all. You have just said no. Don't project,
how
bro.
many times do you think
I've made claims, and I'll post my sources.
How many times do you think you've been refuted since you've been here?
Is this another Coco?
Well,
is this another Coco experience?
Well, actually,
seriously.
Okay. When I make a claim and I say this, and you're saying, well, technically you're off by 0.5%,
no,
so you're wrong.
Like,
you've been refuted.
You said I was lying, and you were actually lying. Like that's just, I mean, how many times do you think that's happened tonight?
Twice.
Is this another Coco experience?
This
must be another Coco experience.
We made a claim and we asked you to substantiate it by posting your evidence, and we are still waiting on that.
Didn't you say Aries failure has nothing to do with stellar aberration? Wasn't that in the title of the paper?
Didn't you say maps don't require corrections? Still waiting on your perfect globe Earth map. Like, come on, Cap. You've done this so many times. You should know better by now, yo. And just a heads up, my mic stuck, so I have no choice but to mute you in order to speak so you guys can hear me.
Oh, and we're so confident about the weight of the planets. I mean, we can go on, bro. What was it, like
Okay.
5 to
So you have
15% maybe?
just to reiterate, you have no working map, you have no working model.
5 to 20%. This is what I mean.
You
We can
guys
have
have
a
no
5% acting like,
no.
yeah, we know the weight of this planet absolutely based on the
Okay,
orbits.
we're talking about flat Earth, and what do you guys
LOL.
do? You quickly jump away from flat Earth.
No. We don't quickly do it. What we do is say, okay, hey, we hear what you're saying, conspiracy pusher. Let's see if y'all holding your own people to your own standard. Let's see if
Yeah, like I
y'all.
said,
Let's see. Hold on,
like
bro.
I said,
Hold on, bro. What we say is, let's see y'all working model. Let's see if y'all got a navigable globe that doesn't have corrections. Because if we could provide, if we could provide a map that has corrections in order for it to function just like you, then I think that's a good baseline. And I feel like we found some common ground. But you are not going to hold us to a higher standard than what y'all hold yourselves, and y'all got 2,000 years of the globe. Stop it, bro. We've been up here for 2.5 years doing Flat Earth Fridays. If y'all don't even have what you asking us for, if y'all don't have what you asking us for, don't ask us for the same thing, bro. You do it first. That's all we saying. Is that? Let me just say the last thing I'll say. Do you agree that that's fair?
Yes.
Okay, cool.
So when I asked for the distance from Santiago to Sydney, how far were you guys off?
I've never mapped it. I've never measured it. But we've talked about this.
200% off.
Hold on, wait, what? And when I asked, how many miles, how many hours,
that the distance from Santiago to Sydney is the distance flying up the coast of South America, up the coast of North America, across Alaska, down the coast of Asia, down past China, and to Sydney, Australia. That's the shortest path. And the actual path is less than a third of that.
Well, I don't know. I don't know what you're talking about. Is this something that happened before I was up here, or before I came back to the mic?
And so to verify that, Qantas Airlines flies that route 4 times a week each direction. And they do it in about 13 hours. Okay, so unless they're going Mach 2.5
amount of time
up the coast of South America, North America, and down Asia, which I'm sure I'm sure the Dreamliner doesn't quite do Mach 2.5, then I think your guys' map is off. And if if the globe needs correction of less than 1%, or 20 miles out of 25,000 mile equator, then I think trying to compare correction to the two maps is kind of a false equivalence.
Well, let me just make sure I clarify, right? Because I know that what you're doing right now is you're trying to hold the AE map as the map that you're trying to destroy. And you know what? That's fine if you want to do that, but that's based on a coordinate system that uses a globe coordinate system, right? But it's all just a coordinate system. So what I actually think is that there's a flat Earth that's wrapped around a globe, and then they take that globe and they flatten it with the AE map. So I think that there's like 2 or 3 distortions. That's my position. I think the AE map is a good reference, but the AE map is used for a specific purpose, right? And I think it's a good visualization of how you could see some of these things, even if it is distorted. That doesn't necessarily mean that the AE map is flat Earth map. And anybody who does say that, I don't think that y'all should say that AE map is a flat Earth map. But I do think that it's a projection from a globe, but the globe is literally derived from a flat Earth, bro. Like literally
not.
Yo, everything was mapped. Everything was mapped as if the Earth was flat and stationary, using planar surveying. All the sky was mapped out. Assuming that the Earth was flat. Everything was done from a flat Earth. That is the first position. Now, and I don't know if they brought up the the royal decree and how they had to map out the whole entire world?
They
He
they
brought it up.
they
I
tried
asked
that
him for that
story. That
steel
was
man. He
funny.
brought it up and he denied it because he thought it was funny. No actual refutation, but he thought it was
Oh, I
funny.
mean, did that
No,
not? Hold on.
I thought it
Did
I thought it was
that
funny
not?
because
Did that not happen?
the question was, why can't we do it now? And you guys said royal decree.
Oh, wait, hold
I
on.
said I am not a cartographer, but that was why it wasn't done properly in the first place. That was the first thing you brought up, which his answer was, because you cried about there being multiple answers and multiple steelmans. And I said, okay, well, that's a valid point because it was implemented, the globe coordinates. Now I am not a cartographer, so no, I did not map the fucking earth.
Yeah, so like what? Yeah, so
Oddly enough,
I don't
no
know why.
one
I don't know why you
who lives in
strawman.
Australia can do it.
If that's what
No one
Proud,
in South America can do
if
it.
that's what Proud said, then you really just strawman the whole position. But why can't we do it now? What do you think that it would take? What do you think that? What do you think? Hold on.
In
Hold on. Let me
Australia.
finish my question. What do you think it would take, without using any reference, to map out a country?
A car and GPS.
Car? No. Without referencing anything. Why were we referencing?
Why would you not reference something?
Because GPS requires correction, bro. It literally, you can't even get a position. Dog, you can't. What do you mean? You talk. Wait, are you telling me?
Is this one of those Allen stories?
Wait. Are you telling me?
God.
You telling me that when I'm using GPS and I move from one position to the next, it doesn't correct to give me a location based on GPS? Are you telling me that's not what happens?
It gives you the correct position. And when you move to another
That's
position, it gives you the correct position.
That's not what I asked.
When you move to another location, gives you the correct position.
That's not what I asked.
It knows. What do you mean correction?
You don't know what a correction is?
I know what a correction is, but I don't know what reference, what you're using it as.
Because they have a specific coordinate system, and they use that specific coordinate system in GPS. And when you move from one position to the next, it corrects and says, "Oh, you move from here to here. This got to be your position." Now we are contending those references. Now I'm not saying that you can't validate how long a street is. Well, if we're trying to determine a country, bro, we would have to be, first of all, we would have to figure out how to go in a straight line, which I don't think that there's any road that goes in a straight line from one side of a country.
You don't know how to go in a straight line?
How would you do that? How would you literally, how would you literally determine that you're going?
Have you ever heard of the continental, when they map the continental US?
But we getting so far off of what I asked you to begin with.
They use visual reference points, right? Peak to peak, straight line, right? And they plot an azimuth.
Yes, it's called plane surveying. Thank you for confirming flat Earth.
It's not plane surveying.
That is what they do. They look straight out ahead. They literally don't account for no curvature, and they plot everything using plane surveys, and then they stitch them together. What you mean, no?
No.
I literally have a plane survey map of America. Why would you say no?
Okay.
Yes, so okay. Welcome to Flat Earth.
Welcome to Flat Earth.
I'll post it up top if y'all think I'm capping.
Oh my God, that's a joke. Okay.
I mean, it's y'all maps. What you mean?
It's no.
It is.
Okay. So when you're mapping, when I want to map the size of Australia, and you say we can't do straight lines. And then you say, "Oh, well, this is how they did straight lines." Which is it?
No, I didn't say, bro. I said it's flat plane surveying, right? And I said it's hard to determine going in a straight line from one side of a country to another because there's no one road going from one side to another. So we would have to have a straight road in order to determine a distance between 2 points from one side of a country to the other. That's what I said. But we're talking about mapping an actual country. So I'm saying this is what I'm just gonna give it to you because we're getting off of the topic. I think it will cost a lot of money and a lot of manpower to do it. Now, why hasn't it been done yet? We haven't had no funding to do it. Now, I do think that we could do it, but how do we do it without referencing a coordinate system was my question to you. Because if you have a way to do that, then let's work together and verify what they're telling us is true. You should be working with us to do that. So if
You know that TFE?
if you have a way to do that without referencing a coordinate system, without referencing something else, so what we can
Do you know that?
validate
Do you know that
ourselves.
TFE measured the southern hemisphere and measured that the longitudinal lines don't match up
Hold on, say it again.
with the flat Earth? So in the northern hemisphere, we know the distance between longitudinal lines, correct?
I think you could determine it on land more than you could determine it on water. I'd be having an issue with
Okay,
determining
right.
distance over water, but continue.
So if I picked Los Angeles and Jacksonville, Florida, okay, and I know the longitudinal coordinates of those two, and I know what latitude they are, and I went to the reverse latitude in the southern hemisphere, and I did the same distance, would they come up with the same longitudinal lines?
No, they actually tried that. It was documented in his pronouncement by what's his name? What's the guy that wrote the book? His pronouncement, where they documented all of these different navigating.
Andre.
What is it?
Andre.
Andre? No, I don't know. His name's not Andre. Anyway, with the guy, the book is called His Pronouncement. And they said they did exactly what Conspiracy Pusher is saying. It's like they assumed a globe of equal proportions while navigating in the South. And they came up vastly off of their heading by hundreds of miles. And this is, I think, before they implemented these type of corrections. I don't know if y'all talked about magnetic declination and all these different type of things where they have these tables to account for your position relative to the sky.
Yes,
and when they assumed this, right, just like Conspiracy Pusher is saying, they were vastly off of their heading by hundreds of miles. So it's just like, why are we not acknowledging these old navigations?
Okay, because we have modern navigation.
Right, we're trying to verify that those modern navigations without the corrections is valid. Why do you need corrections?
Like I said, go from Los Angeles to Jacksonville. We know the distance. We know the longitude lines difference. Go to Australia and do the exact same thing with Perth to Sydney and measure it out. And based on the globe, they come in within a margin of error. Okay, there's your map. There's your
Why
confirmation.
couldn't you have those same measurements on a flat Earth?
That's what I'm saying, bro. Like,
because a flat Earth doesn't have a map.
Okay, wait. Couldn't they just have those same measurements for Antarctica on a flat plane?
So
the land masses.
When they map it out, it maps out to a globe.
Okay, so take those same measurements and put it over a flat plane. I mean, what's the big deal? I don't get it.
And you get 9,000 miles instead of 3,000 miles.
What are you talking about? If they don't have a map, then how are you going to give these comparisons?
Because he's trying to reference the AE map. That's why I said that's all he's trying to do is straw man.
Did anybody actually mention the AE map other than you?
No, that's what I'm saying. Yeah, and I've just said that. How are we going to verify and validate what they're saying? How do we actually hold on, bro? Relax. I want D3 to jump in because he's been diving into this. But this is what I've been saying. You're saying, where's the flat Earth map? Why don't y'all have one? I said, first of all, it will cost a lot of money. And I would want to know, how do we do that without referencing another coordinate system or anything else or any information? We want to validate what they're saying. We want to independently verify what's happening in the South without referencing coordinate system. Now, D3, you could jump in and I'll let Conspiracy Smasher go after that.
Yeah, cool. I think what we can do to get a model is like what Taylor was just saying. You use the data that's already been taken. There's nothing wrong with the data. The data is there. The only issue is that it's being run through a particular coordinate system that references the celestial sphere and imposes sphericity. If we just use a different coordinate system, we can just, the one that doesn't assume sphericity, doesn't worry about the sky, what's going on up there, just uses the measurements that have been taken over the past couple hundred years or 500 years or so. We just use those. And I don't know exactly how to do it myself, otherwise it'll already be done. But I think that's what we need to do as a community, just find somebody who can put that together.
Well, another good test is to take airline flights that are done hundreds and hundreds and hundreds of times based off the globe and see if they match up and the planes don't run out of fuel.
Well, no,
Okay,
because
match up with what?
yeah,
Match up
exactly.
with
They're,
what?
they're
Match up with
matching
the
up.
There's
globe
no
prediction.
But the globe prediction
You
as
can do the same thing over a flat plane.
yeah, as Sacred alluded to earlier, the globe prediction would match the flat measurements that we take because it's derived directly from the
So
flat
you've never heard of
measurements.
Haversine.
Just use a
Haversine
flight
disagrees with
map.
you. Haversine disagrees with you.
Who the heck is
Okay.
that?
If you want to do polar coordinate
Someone's knocking on the door.
measurements, do so. And if you want to do Haversine, do so and see which one comes up closer.
Well, you want to know what disagrees with that? Is planes that fly over 2,000 miles an hour at 80,000 feet and don't curve.
Oh, Jesus.
Jesus,
you don't know how
nothing.
planes
You want to
work.
use planes,
So you don't
brother?
know how
If you want to
planes
use
work.
planes, we can use planes. But you got to use the ones that travel faster than what you're talking about to see what I'm talking about.
Okay, I'll tell you what. Learn how planes fly before making such silly claims.
I know how planes fly, but what are
Do
you
they
saying?
do they behave
Are you
as if
saying
they're
that they
moving?
automatically adjust? Is that what you're saying?
The plane flies at a constant altitude.
Mm-hmm.
Okay.
Mm-hmm.
So it sets a pressure. Altitude is set by pressure,
Mm-hmm.
right? Okay. And the plane just flies at a specific altitude.
Yeah.
Okay.
Right.
So if it's going 2,000 miles, 10,000 miles, 12,000 miles, it's going to still stay at the same altitude. So if there's a curved Earth, then then it flies over the curved Earth, and as it stays at the correct altitude, it compensates for the curve of the Earth.
Does not compensate. If you read the manuals on how those things work, the internal navigation systems, they do not account for curvature, brother. Sorry.
They don't need to on INS. INS is just altitude and heading.
Did you not just say altitude?
Correct. It stays the same
Alrighty
altitude.
Then. Same
That's
altitude, not being correct for curvature, though. That's what I'm saying.
So you're saying that in order to compensate for curvature, they need to lower their altitude?
You have to make an adjustment to go over a curve.
You have to adjust altitude?
Yes, of course. If you're flying at 2,000 something miles per hour, right? You have to make an adjustment. Now, if you're cruising at what you're talking about, like a normal plane, and that's what I'm saying, I really can't argue with you there. I mean, I can, but I'm not going to get into that because it's an annoying argument, to be honest. But that's why I'm using something to where there is no argument. If you're going over a speed where that system is not accounting for any curvature, but you would have to manually adjust that.
No.
Yes.
That's not how planes work.
You can say nah all you want, but it doesn't change anything. So
you can make any claim you want about how planes fly. And until you learn how planes fly, all you're doing is just making a silly claim with no backup.
You can call it silly, but again, you have no backup. You're making a claim that these things are automatically just keeping altitude at over 2,000 miles per hour. Doesn't work, brother.
Yeah, that's
yeah. Like exactly. what's the mechanism for maintaining the altitude over a sphere?
What? How the autopilot maintains altitude
over a curved Earth?
Yeah, the autopilot just flies to maintain the altitude. That's all it does.
Yeah. Well, what's the mechanism behind that?
What do you mean the mechanism?
Because I could say, hey, over a flat Earth, I could just point the plane upwards, angle it upwards, and I could just fly straight. And I could just keep maintaining the altitude. Now, if I take a paper clip and put it over a basketball, and I try to maintain my altitude over that basketball, I have to angle my arm in order to angle the paper clip to maintain an altitude over a curved surface. So the mechanism behind the paper clip maintaining its altitude over a basketball sphere is my arm. What's the mechanism for a plane?
The plane wants to when you set speed and attitude, which is pointing the plane where you want it to go, and you set the autopilot to a specific altitude, it's just going to continue to stay at that altitude. Okay. because
but when
the
you say
air
point the,
pressure,
my bad, go ahead.
because if you climb, the air pressure gets less, then the plane drops. If you go down, the air pressure gets higher, and the plane rises back up to that specific altitude. So
So
that's
you're
how it
saying
maintains.
elevation. So you're saying elevation is how they do it.
Elevation is on land. Altitude is in the air.
Yeah, elevation. So you're saying your altitude and elevation is affecting how you maintain the surface.
It wants to stay at a
Excuse me,
specific air
maintain the altitude
pressure.
over the surface.
It wants to stay
Well, what I'm
maintained at a
saying
specific
is,
pressure.
you said you got to point. You said you got to point the plane in the direction that you want to go. The plane
that's
is
called
pointed
flying.
up. Yeah, the plane is pointed upwards, bro.
Yeah, the angle of
Did you
attack.
just say no? Did you just say no?
I said yes. The angle of attack.
Oh, it sounded like you said no. But yeah, okay. So you're right. So you point the plane where you.
There's a small.
You
There's
point.
a small
Hold on. You point the
inclination of
plane.
the
You
nose.
said you point the plane where you want it to go. The plane is pointed upwards. Now I could take a paper clip. I could even take my phone and put it over the. Hold on. I could take my phone and I could level it over my table. I could tilt the phone upwards, and then I could move the phone over a flat surface and maintain altitude.
Okay. That's
what I want to know is, no, I know that's not what you think it is. What I want to know is, how do you tilt a plane upwards and then have that plane go around a curve without adjusting the heading?
Well, the heading is
if it's just altitude, then you have to show me what's the mechanism if I scale it down, right? Because geometry is hold on. You could scale down the geometry. So I just want to know how you could do that. If I scale it down to a basketball,
no.
Why can't what geometry is not scalable?
It is scalable, but not airplane. Aircrafts flying are not. Well, what about a paperclip on a basketball? No. Do you know what angle of attack is?
Yeah, it's the angle of the plane. I feel like.
Okay.
But I'm not a pilot, but it's the angle of the plane.
So you know.
As a matter of fact, Superfly is a pilot. But go
awesome. Ahead. Okay. Exactly. So you know that there's a difference between the direction the plane is flying and the nose it's pointing.
Right.
Okay. That's positive angle of attack. Okay. And let's say that positive angle of attack is 1.5 degrees. Okay. And you're flying, and as you go around the curve of the Earth and it goes to 1.6 degrees, what happens to the plane? And the altimeter says you're staying flat. You're staying the same altitude. What happens if it goes to 1.6 degrees?
What, the angle?
Angle of attack.
From what?
1.5 to 1.6.
Well, that means it's going to angle upwards.
That means that the nose is still pointing the same direction. The plane's moving at a greater distance than the nose. Okay, so if the nose is still pointing relatively the same direction the entire time, and the angle of attack goes up, then the plane would be, in theory, moving across the curve of the Earth, and the nose of the plane stays the same.
No, you need a mechanism in order to keep that nose upwards while going around the curve. Because look, yeah, you're saying the air pressure causes it. You're saying that air pressure makes it go up and down. You didn't say that air pressure angles the plane up and down.
It has nothing to do with angling the plane. I'm talking about the direction.
So you need that.
I said the direction of the plane. The nose is staying this constant angle, but the plane is moving 1 degree down, or 0.1 degree down. Okay, so now the plane is curving over the Earth, but the nose is still staying the same.
So
you're saying 2 degree angle of attack, and you keep the nose pointing in the same direction, then the plane will actually start to die. Will start actually lose altitude. Okay, but the nose of the plane is still pointing in the same direction. You have to know that the angle of attack is the difference between where you're pointing the plane and the direction of the plane. And as your Earth is curving, that angle of attack moves ever so slightly to adjust for the curve of the Earth, even though your nose is pointing in the exact same direction the entire time.
And what's the mechanism behind that? Because the only way to adjust the angle of attack is, so the atmospheric pressure changes the angle of attack?
The plane wants to stay at a specific altitude.
Conspiracy pusher, answer my question directly. Does atmospheric pressure change the angle of attack?
Yes.
I've never heard that. Superfly, maybe you could correct me. I've never.
Well, see,
the only thing I've ever heard.
The thing is like it may do that, but if you're assuming that atmosphere is curving over a curved surface, then that would work. But we're saying that it doesn't do that, bro. That's the whole point.
Okay, so you're just saying no.
What I'm saying,
we don't believe.
No.
Because
I'm saying okay.
What I'm hearing you is if that's true, then we have to agree that the Earth is a globe. But we can't afford to say Earth is a globe, so I'm going to say no.
Bro, you asked me what I'm saying. So what I'm saying is that you're assuming that air is going over a curved surface. I'm not assuming that. That's it. Bottom line, done.
But I'm not. But we already know.
How do you know?
That they're WGS 84.
WGS 84 is what? What is that exactly? Do you understand what
the globe datum?
It's a globe datum. Now this datum, because it's not actually just a datum, but this is a model, brother. It is not reality. There's a difference between a model and reality. Do you understand that?
Perfectly predicted. It's a perfectly predicted model.
It's not predicted. See, that's another thing you've misconstrued. It is not predicted. Okay? What it is they are taking a horizontal datum, as Sacred pointed out before. The horizontal datum is then corrected, as him and Proud pointed out before, to things in the sky with deflection of the vertical. This is how it all matches up and aligns. The points on the surface are still the points on the surface. Now, that datum that they have is derived from underlying plane survey data. Those points are not accounting for curvature at all. So therefore, the datum that you're talking about that is connecting everything to the reference ellipsoid and the WGS 84, what number it was, that is all tied in together through that mechanism. You understand? They are making corrections there to match it all together.
That's a great story you just
told. It's not a story. Would you like to go to the NOAA website and see how it's done, brother? I've researched this.
The NOAA website, the one that shows us the globe.
Yeah, exactly. Look at how they do it. Look at exactly how they do it. I'm telling you exactly how they do it. You take plane surveys. Hold on. I'm gonna finish up real quick. You take plane surveys, okay? You pick points off of that plane survey, okay? And you match that to what's called a reference ellipsoid. The reference ellipsoid is also they also use gravimeter data, right? And they make the geoid model. Okay, so you've got two models. Okay, you've got the reference ellipsoid, which is a theoretical model. You have the geoid, which is aligned to the reference ellipsoid. That is a theoretical model. It has data. Yes, the data is real, but the model is theoretical. You don't get sphericity until you go into geodetic surveying, and that's where your disconnect is.
Okay, so how far is the planar?
What do you mean by how far? What do you mean?
At what point in time does planar become geodetic?
The rule for that is about 100 square miles.
Okay, so 10 miles by 10 miles.
Okay.
66 feet of curvature negated.
No, 666.
So the better question
make it right.
So wait, before we continue, the better question there would be, why do we assume it ends there? Okay.
Because
and the reason for that is because they are using the celestial sphere. That's why.
No.
Yes.
So planar survey, the sagitta is less than an inch. So there's no point in doing geodetic surveying if you're going to just do short distance planar surveying. When you start going to geodetic surveying, then obviously the Earth's curve is gonna come into effect, and so you have to use
No.
Earth curve. Yes.
You're
What do you think of
assuming
total
Earth
station?
curve. Again,
What?
you're not understanding the
No,
concept, brother.
we're
I'm gonna explain
measuring
it again.
Earth curve.
I'm going to
There's no
explain it
assumption.
again. I'm going to
No.
explain it again. The
Oh,
Earth
Jesus.
curve, where does it come from? Why is it not in the planar survey? Right? Why is it not there? Because it doesn't exist
have
there.
enough curve to worry about.
You're incorrect.
Planar-
The reason it's not there is because it's a different system. It's called planar surveying. Then you go into geodetic surveying. What does geodetic surveying assume? It assumes an ellipsoid model.
No.
Yes, it does, brother. Go look this up. Yes, it does.
I do. I know this.
No, you don't. You obviously don't. You obviously don't.
Look at any survey book, and just look up the word level. And
Yeah,
tell me
I understand
what you
level
find.
very well. It comes from sea level. I've looked at that as well. This is actually
Okay,
how we
and
can
sea level is based off of what?
Sea level is based on getting a datum from the sea level at the shores. That's what it's based on.
Can
And
I
it's
clear
based
up a
on
lie that was just
No, it's the
stated?
Yes, it
average
is.
Hold on one second, so we got a few people
Yes, it
ahead.
is.
And they want to
From
comment.
there,
just
it is
lied,
tied
though.
to a geodetic. It is tied to a geodetic benchmark, which is then referenced into the ellipsoid model. I know exactly what the fuck I'm talking about, brother.
That's correct. That's all I'm saying. Geodetic is to ellipsoid models. Yes, they are. Just
Yes,
look
they
it
are.
up yourself.
Yes, they have to be because that's how they measure them.
That's
my
not how
gosh,
they
the
measure
gas
them.
artists.
That's how they tie them together. That's how they
Okay.
tie the flat plane
Have you
survey
used
datums
have you used
to the
a
ellipsoid
theodolite
model.
or a total station?
Have I used one?
have.
No. She has.
Who has?
Taylor.
Taylor, take
Taylor's
it away.
used a total station?
Theodolite.
Okay.
It didn't have a laser rangefinder, so it wasn't technically a total station, but yes.
Okay. So find a total station, measure 2 points over 1.5 miles, and tell me what you get. Find anybody who has a total station, measure 1.5 miles, and tell me what you get. And you'll find out.
I don't
You'll
have
find out if what the baseline is, and you'll find out what the reality is.
I've talked to surveyors who actually have done that and said they didn't find any curvature. I did more long distance observations.
Anecdotes are awesome.
Okay, well, haven't you been doing
What
that
you
all
supposed
night?
to reference? And I'm not referencing the actual
A
measurement.
person with a total station and measure 1.5 miles.
Have you done it?
Yes.
Okay, well, that's great.
We got a
and I've
couple
looked
hands.
at
Nathan
things
wants
with
to chime
theodolites
in.
too, and they.
Well, hold on. It was Superfly first, then it was Nathan. But let me just go ahead and just correct you. Because he was talking about atmospheric pressure changes the angle of attack to account for curvature.
Yes.
That's not what it does. Based on the air density, you don't have to angle the plane at certain altitudes because of the density of air.
Never made that claim.
Bro, that's what we're talking about, accounting for curvature. And you said that this was
angle of attack.
Hold on, bro. Don't start censoring me. Don't censor me, bro. Don't censor me. Don't censor me because you said atmospheric pressure was how they account for curvature.
Yes, and what's the difference between atmospheric pressure at altitude? The air density.
Right. So that doesn't mean it's counting for curvature. That means because the air density is different, they don't have to angle it at specific angles. It doesn't mean it's curvature. It has nothing to do.
Anything.
It has nothing to do with curvature at all.
I didn't say the angling. You inserted angling.
Bro, that's how you account for curvature in all demonstrable curvature accountants. That's how you go along a curve.
Cool
you have
story. I'm sure you do that.
Then demonstrate it.
Sure
So then demonstrate. Yes, I have. I've done it with different spheres on a local scale, and I'm like, yo, how can I?
Use my paper.
Hold on. Let me just read you real quick so I don't get interrupted. I was like, okay, how can I demonstrate the causal claim? The first thing what I did was I took a sphere and I put it under a body that was angled up, and I spun the sphere underneath the body. And I'm like, okay, this is a way where I can maintain the angle of the plane. The plane would essentially be traveling a distance over the sphere, but the sphere has to be moving underneath the body, the plane. But I'm like, but that's not how planes work. Like planes don't separate themselves from the earth. Like it all moves together. So I can't have the point of curvilinear motion on the Earth. The Earth doesn't spin underneath a plane. So I'm like, well, that doesn't work. So I'm like, well, how else can I get this body above the sphere to go around the sphere while maintaining its angle? And I cannot do it without adjusting the angle of the plane. So if you could do a conspiracy pusher, and maybe you have, and maybe you could show us, and then if you can, I will concede that point and I will never bring this back up again. If you could go get any object and maintain its angle while maintaining its altitude and go along a sphere without changing that angle, I will never bring this back up again. But how much you want to bet when Conspiracy Pusher leave this space, he will not post that demonstration because he told us geometry is scalable. So he should be able to scale that down. So if he can do that, I'm telling you, bro, I will never bring this point back up. But I'm telling you, he will never post that. As a matter of fact, I'm going to ask you right now, Conspiracy Pusher, are you going to post that demonstration? And then we'll get to Superfly after this.
Okay, so you want me to do a demonstration that shows scale geometry, scale velocity, and scale air density to prove my point. Did I hear that correct? Did I hear that correct?
No, density of the air. No. Density of air doesn't matter. Velocity doesn't matter.
Exactly. It does.
All I care about.
That's my whole point.
All I care about. Well, what do you mean? That's your whole point. None of that has to do with curvature.
How do you think the plane maintains altitude?
Because the Earth is flat.
Oh Jesus. This is
tough. Otherwise, when I put an object and I'm maintaining that angle that it's at, right? Because the plane is angled upwards, I have to tilt the plane to go around that curve every single time. Whether it's my arm, whether it's God's finger, no matter what it is.
What air density are you using in your experiment?
No matter what it is, there's got to be a mechanism to cause that plane to angle over a sphere.
Okay, what air density are you using?
He's claiming it's the air, but he doesn't understand that the air isn't curving around the globe. That the globe is a model. You
can't afford the air to curve around the globe, otherwise you have to give up the flat Earth. Okay, so your presupposed conclusion is kind of shining there.
I'm not the one presupposing. I already explained to you how it gets close.
You just said that the air is not curving over the Earth. Why? Because the Earth is flat. Okay, that's the presupposed conclusion.
No, you said how is it?
Confirming the consequence.
No, you asked me. You said how is it? I'm giving you how that works.
In Sacred, I'm asking you in your experiment with a paperclip and a basketball, what velocity are you using and what air density are you using to keep that object over the basketball?
Any velocity. I can go super fast. I can go super slow. Okay. Every single time I have to angle my arm. Every single time I have to angle my arm. Every single time. I have to angle my arm in order to affect the angle of the object to go around a curve, maintaining its altitude.
Okay, so you're going around the equivalent of the Earth at about Mach 60 to maintain the...
Something on this specific topic. Just check your messages. And can Conspiracy, whatever this guy's name is, mute his mic while other people are speaking, have respect, because interrupting and making noises while people are speaking is a bit annoying.
Yeah, you could do that, Conspiracy Pusher. Mute up, and then we'll pass the mic back. So mute up right now. Thank you, Nathan. And we're going to go to you right after Superfly because he is a commercial pilot, and I do want to hear what he got to say. If you can't do it, I'll do it for you. Only muted you because for some reason you can't find the mute button. Go ahead, Superfly.
Yeah, can you hear me?
Yes, sir.
Hello? Clear.
Okay. All right. Yeah, I've never heard so much bullshit coming out of one guy. I'm sorry to say that. But first of all, I wanted to ask that guy... Conspiracy, what's the barometric pressure at 35,000 feet that most commercial airplanes fly? Let him answer. Come on, Conspiracy, I'm waiting.
Come on, Conspiracy, we're waiting.
I didn't hear. I didn't hear what he said. Can someone tell me what he said?
Yeah, what is the barometric What is the barometric
I
pressure
can't hear everybody's
at
talking. So
35?
what did he say?
He's
He's
asking.
Google.
Drop down,
For Google to
drop
load
down, and
up
come
that.
back up because I want you to hear him directly. I'm not going to repeat
Okay.
Yeah, better if they just hash it out.
He's stalling for time. His Google's acting a bit slow.
it.
He did that with Sacred earlier too.
Got to connect to that Wi-Fi while you're in the car. Wi-Fi on full court press on his ass.
Okay, go.
Can you hear Superfly?
No.
Yeah, I can hear him.
Okay, now
Can
I
you hear me?
Now I hear
Okay.
you. Go ahead.
What is the barometric pressure at 35,000 feet?
How does that affect anything?
Well, you're the one that's saying that barometric
Okay,
pressure
so let's say
dictates the curvature of the Earth. Now,
okay.
please don't cut me off.
Barometric.
Don't cut me off. Don't cut me off. I got another question for you.
Oh, you
If
asked me a
you've
question.
flown,
Sorry.
if you've flown on a commercial airliner at 35,000 feet, 40,000 feet, doesn't matter, 25,000 feet, and they're at altitude, and you got a marble from the front, and you let go of that marble, which way is that marble going to roll, backwards or forward?
Backwards.
Then what does that say?
You're at positive angle of attack.
What?
You're at positive angle of attack.
Okay, so if it's positive and you're angling upwards at 1.3 degrees, like you say, then how is it going to follow the curvature of the Earth?
Because the barometric pressure would cause the plane to maintain altitude over the curve, and the angle of attack increases without the direction of the nose changing.
Whoever told you that bullshit is wrong, and if you just made that up, you're wrong, because barometric pressure does not dictate the curvature of the Earth.
What?
You're speaking to a commercial.
Am I fucked up or what? I mean, what you're saying is that barometric pressure is holding the airplane, and it's just like what Sacred was saying about the basketball. If he's holding an airplane, what is the mechanism that's holding the airplane? What's making it go up, or what's making the angle of attack?
Air density.
His arm, right? He's holding the airplane. He's holding it at a certain altitude. That you hold a certain altitude. You said, the fuck, what did you just say? Oh, autopilot. Autopilot is just a mechanism that holds altitude. It has nothing to do with curvature of the Earth.
Okay.
I mean, you're like that. I was a corporate pilot. But what you're saying is, but I held a commercial license. I mean, I held the highest license that a pilot could get, which is an ATP, air transport pilot.
Right. Okay. So have you used the Haversine formula for distances?
No. We don't. We didn't use that because everything's automated.
Okay. So in flight school, you didn't have to use Haversine formula?
No.
Traffic light. Then take the third right.
Okay, so.
But here you are asking me questions that you can't even answer the ones that I give you.
Okay, so
yeah, let's not deflect conspiracy. Put your stay focused.
So my point is barometric pressure is not the curve of the Earth. Barometric pressure or air density is what the mechanism for the plane maintaining its altitude.
You're wrong. You're wrong. You're dead wrong.
Nuh-uh, you're wrong.
Nuh-uh.
Nuh-uh, bro.
Okay. What you're saying is that you're saying that barometric pressure. What you're saying is barometric pressure is like a device that's holding the aircraft or any aircraft at that to a certain altitude, and it's not.
How does a plane know what altitude it is?
How does an airplane know what altitude is at?
Yeah. How's the altimeter work? What are the inputs to the altimeter?
Oh, here we go. No, I'm not going with that. I'm not going there.
Wait,
no, I'm not going there. I'm not going there because It's
You're
like
an
if you
ATP.
fly a Cessna 172 and you take it to 5,000 feet, that's all you do. You just take it to 5,000 feet, and then most Cessnas 172 don't have a freaking autopilot, but you just take your trim and then you hold the altitude. It can go up and down just because of air currents, but once it's not like, oh, I'm going to set the barometric pressure. No, you just
Wait,
set the
what
altitude.
is the
You set
input
the
to the
altitude where you
altimeter?
want it.
What is
You
the
hold the
input to the
altimeter
altimeter?
where you want it. You hold the altimeter where you want it. That's all.
Okay, what's the input to the altimeter on an ATP?
What on an ATP?
Okay, so any transport plane, okay, regional.
I'm done. I'm done
Okay.
with this guy. I'm done with.
Yes, you are.
Ding, ding, ding. We got a winner.
Hey, what up, Dirter? Good to see you, bro.
It's been great, guys.
He's spewing. No, he's spewing out. He's spewing out a bunch of bullshit. He's talking nothing but nonsense. You're talking nothing but
Past his
nonsense.
bedtime, y'all. It's past his bedtime.
You're just talking
Sorry, Super
nonsense,
Funny
bro.
got packed up.
Hold on, does anybody, real quick, does anybody have a real a challenge or a question for Conspiracy Pusher before you dip out of here? Okay, I know people had his hands.
Yes.
All right, just real quick before you got to go.
Send me whatever you said you got with your total station, please. What did you get, by the way? Like, what was your data?
I'll show you all the total station information.
What happened? Like you said, 1.5 miles. What'd you find?
I'll show
you. Can you? Okay. Maybe I'll share it up here then, if you don't want to share.
Guys, it's been great. I love this. This is awesome.
Better luck next time, Pusher.
What do you mean?
Dude, it had to be like 10 times.
Better luck next time, gang.
You know you only grab a mic once every
dynamic.
17
you
months.
might want to research.
Yeah, we'll see
You might
him
want to research
next
how the
season.
globe is
Three more
developed, bro.
smashes. 3 more smashes going to add to the list. This is awesome.
Since where? Everything intact around here. All I see is you talking about, I don't know this or I don't get that. Like, oh, send me this, send me that. Oh, don't worry. We got all the citations in the nest, brother.
Aries didn't talk about aberration.
Oh, we forgot to go back to Aries failure and stuff. I can't
he lied
believe
about
he
so
said
many
that.
things. Like, I don't say that lightly either. He absolutely did.
Oh my goodness, I can't believe he said
I agree. He was lying about so many things and misrepresenting so many things. He was twisting what people say. He was leaving out stuff. That guy is so deceptive. It's unreal, man. I don't know how you guys have the patience for it.
It's my birthday, man. Got to be in a good mood. We don't get Conspiracy Pusher around here too often. So when we get to step on him real quick, we gotta let him just come in here and just get flat smacked a little bit. But appreciate y'all for letting us get through that, or at least trying to anyway.
Sacred, he's just talking nonsense, and I just can't deal with that kind of bullshit.
Yeah, man, I agree. Hopefully he does look at some of the stuff that we posted up top, which he probably won't. But
yeah,
I mean, it's dead.
He's not gonna look at it.
And I bet you he will not post that demonstration. I guarantee
he's got no
do.
demo. He was crying about your requirements for it. So you mean I gotta do this and scale this and scale this and scale this, and he was alluding to the impossibility of it. It's like, yeah, bro, we know.
Oh, look, somebody put in the thread when Neil deGrasse Tyson literally said that it's pear-shaped, oblate spheroid, which is like the first thing he denied that I said off the rip. He's like, oh, he didn't say that.
Funny as hell. Nathan, yo, that those docs that you sent me, I gotta read through it because this is on fire. I don't know if you want to touch on it real quick. If not,
no, I only sent it to you because I thought to myself, he was trying to pancake stuff and like make it hard for you to like pick up what he was saying. So I thought, well, let me just go and kind of go over everything he's saying and see how it adds up. So I sent you that so that you can basically see how he was twisting around the argument. So he was taking one part of what they say and then adding other stuff that's actually not actually accurate. So I just wanted you to see what he was Because then he started to say that you don't need to adjust the nose to change the angle of attack, which is a lie. He said you just need to adjust the pressure, but that's not what happens. It clearly says in what I sent you, you have to adjust the nose in order for the angle of attack to change. So like I thought to this, why is this guy doing this? Like literally just leaving stuff out, misrepresenting, twisting the thing. And then he started talking about barometric pressure, and it's like, no, that's not the argument. And I even went and got the actual mainstream argument, what they say, and it was not what he was saying, and that's why I sent it to you, so you can see that where he was twisting the argument.